Pandas. Pandas is a library where the major data type I would say is called a data frame. It will be very similar to a table in your Excel sheet or something. Okay. And you can do different operations on the table, just like how you do calculations in your Excel sheet. Okay. The only difference is we'll be using the Pandas library and doing it in Python. Okay. So just loading a sample data set. Okay. Yeah. So I'm just loading a sample data set. Okay. This is called the iris data set. I think Nirav must have mentioned this in the first class. So what's the difference between classification and regression? Anyone? In the case of supervised learning, what's the difference between classification and regression? What's the basic thing that you do in machine learning? What are you trying to predict? Classification regression base. What do you want your machine learning model to do? You can also put it in the chat box. Okay. Okay. So what I'm trying to do here is I have a task here, okay, where I have three different flowers, types of flowers, okay, that is represented by name called species, okay. We're trying to identify the species. So let's say you look at a flower, okay. Let's say a rose, jasmine, something, something. How do you identify which species that does that flower belong to? What do you see? Can you tell some features that you'll see through your eyes and try to guess the species? What are things that you see? If I give you a flower and ask you to look at it, eh, yeah, color is one. Maybe the number of petals, the size of the petals, how big it is, so on, so on. Okay. So these are all different features that you will use to describe that particular flower. Very similarly, I'm not using color as a feature here. Okay. I'm using different features such as length of the sepal, length of the petal, width of the petal, and so on. And based on the combination of these four, I'm trying to guess what flower it is. Okay. So iris is a variable here. I'm loading a data set, the iris data set. I'm assigning to a variable name called iris. Okay. And so there is a dot head method. So if you just put iris, I have 150 data samples with me. Okay. So 150 rows. Rows indicate the number of data points that I have. Columns indicate how many features I have. Okay. The objective of the data set, or what do you want to do is get these four features as input and predict the species. Okay. So if you put dot head, you'll just get the first five instances. If you do dot tail, you get the last five instances. Okay. This is all inbuilt into pandas. Okay. Again, very similar to your NumPy array, you can also do indexing. So iris, I'm putting sepal length. So I'll only get this column. Okay. And its values. If I just want the first element in sepal length, I'll just put 0. I'm doing indexing. The columns attribute gives you a list of column names. Index gives you what's the start, what's the end, and so on, indices. And if you want an element from the first row, so one here means second. Okay. Second row and second column. Okay. You can do dot ilock. Okay. This is how it is. And again, you can get some statistics. Again, these statistics will explain later in the coming classes along with linear algebra. So this is different statistics such as mean, standard deviation, mean, and mode. Each one has his own function that you can use to get your output. And if you want a summary, okay, of the whole data frame or table that you have, you can use the dot describe function. So it has information about each column. Okay. So let's say what's the mean, what's the standard deviation, what's the maximum value, what's the minimum value, how many samples you have, all the information provided in a table format using the describe method. Okay. In some cases, let's say you're not able to measure the petal length or something. In that case, what will happen is there'll be a missing value. Okay. There'll be a missing value, and you just don't want to take that example into consideration. Okay. For that cases, you can use iris.drop NA. Since we don't have any missing values in this data set, nothing has changed. I'm not dropping any rows. Okay. Dropping rows with missing values. Okay. And one more thing, if you just put in place equal to true, okay, if you do this, if there is any missing columns, the number of rows will reduce after doing this. Okay. And after doing this, you have to assign it to the same variable name again. Okay. If you don't want to assign it to same variable, you just want to do the operation in place. So this is called in place operation. Okay. So you don't need to assign it to the another variable. Okay. You can, everything happens within the table itself, and that's done. And the other thing is dropping duplicates. If there are any duplicate rows where the values are repeated again and again, you don't want to use them. Just use the drop duplicates method. Okay. You can see the advantage of pandas here. Okay. If you want to do these things manually, okay, you have to write code by yourself again and again for whatever operation that you want to do. Pandas makes it easier. It already has inbuilt methods. Okay. Uh, some more things like grouping. These are all things that you do in Excel. Okay. Similar things, I'm doing it in pandas. You just think of it like that. Let's say I want to calculate mean of just Setosa species or Virginica species. Okay, I can use dot group by and grouping it by species, and I'm calculating the mean value. See, this is what I'm getting. And you can get how many unique values you have, how many species you have in total. So you have Setosa, you have 50 data points, Versicolor it's 50, and Virginica it's 50. Okay. And very similar to NumPy arrays, you can, so what I'm doing here is creating a new column. Okay. And the operation I'm doing is sepal length plus 2. Okay. Initially, how many columns did I have? It's 5 columns. Okay. Now I want to create another column called new. And what I'm doing is I'm just using these values and I'm adding 2 to it. Okay. This is what happens. Let's see. Sepal length is 5.1. New is 7.1. So it's 4.9 here, it's 6.9 here. Okay. Now you don't want this column at all. You just want to delete this column. You just use the drop method, mention the column name, and also specify axis equal to 1. So axis equal to 0 means you'll drop the row. Axis equal to 1 means you'll drop the column. In Python, everything, the first initial dimension you have always represents the row. The next one has columns. Okay. Drop. And you can also do sorting and other stuff. Okay. You can sort the table according to values. If I'm sorting by sepal length, ascending equals true means I'll do it in ascending order starting from lowest to highest. So it starts from 4.3 to 7.8. And as you can see, the indices are also shuffled, meaning the order has changed. Okay. These are very basic operations that you can do in pandas. Okay. Okay. I've also shared the notebook, right? I hope everyone has gone through the notebook with the collab link I've shared yesterday. Take a few minutes. Okay, try to run these cells by yourself and see what happens. Let's say you create a new column. Let's say it's not new, you create old or something. See how it works. Okay. I'll give you all 5 minutes to work through the notebook now. And then we'll be moving on to the other library called matplotlib. Okay, which will help you just like how you create charts in Excel, right? That you'll be doing it in Python. Okay. And let me know if you have any doubts before we move on to the next session. Any doubts? No? Is there?
அந்த அக்கா போயிருங்களா அது கூட
Okay, so we'll move on to the next session. Okay. In this notebook, I have three different packages mentioned. I mean, four actually. And you can also notice, so NumPy is a package name. Okay. I'm writing import NumPy as NP, meaning I don't want to write NumPy again and again. Okay, in my code. So just I'm using a short form called NP. And also another way, if you know what function you're going to import, you can do it using from matplotlib import CM. CM is the function that I want to use, a model that I want to use. Okay. So these are all different ways of importing your packages. I'll run it. Okay. Uh, yeah. So SciPy and everything, it's a bit. So I mean, have you all have any idea about what optimization is? What's the minima, maxima? You might have studied it during your high school, I guess. Anyone? What do you do in optimization? Finding the minima, finding the maxima of a function. Any idea? Okay. Even if it's no, just say no, so can teach accordingly. Okay, yeah, you must have studied it, right? Differentiation, integration, all these stuff. Okay. Finding roots of a quadratic equation, all those things, right? Like square root of b square minus 4ac by 2ab and all those things. Okay, very similar. Okay, but if you don't want to deal with quadratic functions, if you have if you have cubic functions like this, okay. So this is an example. This is what I call my objective function. Okay. What I want to do is, let's say, maximize this function. What value of x should I give so that the function is maximized? Maximize meaning, let's say if I put 2, if I give x as 1, okay. So it will be 4 times 1 to the power 3, that's 4, minus 3, that will be 1, plus 2 plus 1. This will be 4 again. Okay. And you can put minus 1, you can put 2, whatever value you want for x. Okay. You try all these different combinations and you try to give me the maximum value of this specific equation that I have. This is what you can either maximize or minimize. This is what op optimization is about. Try different values of x, try to get the highest or lowest possible value. Okay. But what will be the problem here? Anyone? What will be the problem here? I just what will be the problem here? You have to try an infinite number of combinations, right? That's the problem. So you want to write a function that will make it easier for you. You don't need to do it by hand. Okay. So I'm defining the objective function. Objective is the function here. X is my input. And very similar to the equation I have here, I'm returning that value. Okay. Let's say my objective, I'm putting 1, x as 1, it's 2. It's it's plus 1 and minus 1. Okay. Let's say 2, it's 25, it's 3, 88, 4, 217. If it's minus 1, it's minus 8. Keeps increasing as you keep increasing your inputs, and it keeps decreasing as you decrease your inputs. Okay. So what I want to do here is finding roots. Roots meaning I want to find x such that this objective will become 0. So I have the root function from SciPy. I'm passing in the objective and my initial condition. Initial condition meaning where I should start searching from. Okay. And the value of x is around minus. So this is the value of x. Say it's minus 0 point, showing minus 0.3. It's almost 0. It's not exactly 0, but it's almost 0. So you put 4, 5, 0, 4, 5. See, it's very close to 0. And minus 0, 1 means it's 10 to the power minus 1. Okay, 3.045 times 10 to the power minus 1. Okay, that's what it means. E minus 0.5 means 10 to the power minus 5. And if you want to see how the function differs, okay, so I'm giving np.arange. What does this do? Anyone? Yesterday I explained about this function. What does this do? Come on, try to remember what does this do. Okay, what does it give? What's the output for this? What's the data type? Since you're using NumPy, it's an array. What does the array contain? Okay. It will again create an array starting with minus 2000, ending at 2000 with zero point 0.1 steps in between. Okay, very similar to range. Okay. And so I'm using the PLT, meaning it's the matplotlib package which I'll use it for plotting. Okay. This is how the function looks like from 2000 to minus 2000 to 2000. Okay. I see this how the curve is. Can anyone tell me what's the minima and maxima of this function? Yes, minima means where the minimum of the function will happen. Maxima means at which point the maximum of the function is being attained. Okay, at least in this specific plot, where is the minima? Where is the maxima? Try to answer from this plot.
Minus 3 will be minima and 3 will be maxima. Like at the point
Uh,
of 3.
yeah, so minus 3 will be the minimum of the function, not the minima. Minima is minus 2000. Maxima is 2000. And the maximum value of the function is 3. E10 means 10 to the power 10. Okay, yeah, very good. So again, uh, if you there is no local minima and maximum being okay. These are all concepts, some sort of advanced concepts where a function does not have any local minima or maxima. Okay, I won't explain this right now, but maybe in the future classes I'll keep explaining. Okay, this is an empty array being returned. And also again, if I want to minimize this function, this is my objective, this is my input. Let me plot this. Okay, this is my function I have. Okay, let's say for this specific part, okay, where will be my minima and maxima for this specific curve? My initial condition, I'm giving it as 1. So I'll start searching from here. I'll go keep searching. What will be the minima? So it will be around minus 2, minus 2.5, right? Let's check. Okay. If I start from this side, if I start from 1, it will come around 4. Okay. And that is what I'm getting it. Okay. And the value of the function is minus 1.4. That's almost what I see in the plot. Similar thing, you get different local maximas, local minimas, so on. Okay. This is your maxima. Maxima, I'm getting it around 0.79. Okay. See, around 0.79, I'm getting the maximum value around 7.07. So these are all different maximas. These are all different minimas. And you can also remember that you can have multiple local minimas and local maximas because the curve is like this. Okay, this is done. Okay, these are all multiple variable cases. You have last time it was only x, now you have x and y. Okay, these are all things that you can run it by yourself and check later. If you have only a single variable, you can plot it in 2 dimension like this. If you have two variables, you need to use 3D plots. See, this is how the surface looks like. This is my x, this is my y, and this is my value, objective value. And the minima the minima is obtained around this point, 0, 0. Okay. And if you want to convert this into 3D, you also have something called contour plots. This is essentially what you do is cut it into slices and visualize it in 2D. Sometimes you can't do this 3D visualization, so you go for something called a contour plot. Okay? And the minima is somewhere around 0 and 0 here. Okay. You can do the integration also. You have differential equations. These are all things I leave it to you. Okay. So as and when you come across these mathematical concepts, you try to run this code piece also by yourself. Get familiar with it. Okay. Uh, yeah. And moving on to plotting, I'm again loading a data set called the Titanic data set. Okay. It says it contains data about the passengers in the Titanic ship. Okay. How much fare they paid, what class they were in, what's the, did they survive or not, where did they start from, are they still alive if they survive, were they alone, were they with a partner. These are all different features about a person that they can use. So again, I'm using drop any, meaning if there are any missing values in any of these columns, drop it. Okay. This there are missing values, so I'm dropping it. Let's okay. I want to visualize the relationship. Okay, just like how you do in Excel. My x-axis is fare, y-axis is age. Okay, this is the plot I've obtained. Okay, what conclusion you can get from this? Anyone?
Like we can comment about the average age group.
Yeah, that you can get, and is as you can see, with increase in age, people are also having higher
The,
fares. Yeah,
yes.
yeah, correct. Absolutely right. So if you want to visualize some other relationship, you also which town they started from. You can use the hue argument. Okay. So orange indicates they are from Southampton, blue indicates they are from Cherbourg, green meaning they are from Queenstown, and so on. Okay. This is called an LM plot. So here you don't see the relationship line like this. Okay. If you use the LM plot function, you can also have a linear regression model along with it. And this is for call, if you give the call argument as alive. For alive, you get a separate yes, you get a separate plot. No, you get another plot. Okay. And if you want to see something called a histogram, okay, so basically how many paid rupees 100, I'm getting the count. Okay, it's essentially the variable that you have in your x-axis and y-axis will be count. Let's say 50, I mean around 40 people paid 20 rupees. Okay, this is essentially your count that you're having. This is what I call a histogram. Okay, and I've put links to each function here. You can also go through the documentation. You have many different arguments that you can put for your customization. Okay. And then you have something called box plot, which essentially is like your, again, I don't want to go into the details. Okay. As in when you apply it in the course, you'll know, okay, where all these plots will become useful. Okay. Then you have group bar plots. Okay. These are all things very similar to what you do in your spreadsheets. Okay. So kind meaning I want a bar plot. My x-axis will be who meaning woman, man, and child. My y-axis will be age. Hue meaning the different colors represents which class they are from. That's it. As you can see, if they are a child, they are having less age. Okay. And these are all the inferences that you can get from this plot. And moving on to one more package. Uh, these are all the previous packages that I went through were specifically for machine learning. Okay. Here, so there are two different paradigms. I think Neerav must have explained. There is something called machine learning. There is something called deep learning. Okay. If you want to do deep learning, you have to get familiarized with the PyTorch package. You don't need to uh, dive in depth. Okay. Array is for NumPy, tensor is for PyTorch. This is what you have to remember. Okay. So very similar to how you create an array, you have the tensor function that can create a tensor. Very similar to NumPy array, you also have different attributes like shape, size, data type, and everything. You can also convert a NumPy array to tensor or a tensor back to NumPy array. These are different methods that you have. If you want to, you can create once like meaning I want to create a vector or matrix of this particular tensor shape. Okay, just fill it with ones. Ran like meaning it's a random vector. Again, torch.ones means every element in my matrix of shape 5 times 5 will contain 1. You can join two different tensors. You can do matrix multiplication. Okay. You can do element-wise multiplication. You can get the sum. You can get the mean, get the minimum. You can get the maximum. Very similar to what you have in NumPy. Okay. But at the end of the course, you'll get to know how to use PyTorch for deep learning and how to use NumPy and everything else for machine learning. There are some very crucial differences between tensor and NumPy. Okay. Again, these will be explained in the upcoming classes. Any doubts in all these packages? Because these are the things that we'll be using throughout the course. These functions that I mentioned in the first two classes. So any doubts, clear it up right now because the course will get more and more difficult from each lecture. So any doubts, it's better you clear it up right now. Again, I'll share the notebook so you can keep running it by yourself. Keep tweaking things, get to know how each thing works, go through the documentation and so on. Okay. Okay, I got the answers in the chat. I didn't see. It was good. It is okay. All the answers are good. Correct. Okay. I think if there is no other doubts, nothing else. That's it for today. See you all tomorrow. Tomorrow, Rituraj will be taking the course. We'll start with linear regression and basics of linear algebra, I guess. Thank you then. Thank you for attending.
Good evening, everyone. Thank you, sir. I take this opportunity to deliver the vote of thanks on behalf of Department of Computer Application, Meenakshi College, to extend a heartfelt gratitude to Mr. Roshan for conducting this enlightening session of Python programming. The session was truly informative and essential. I would also like to express my gratitude to all the participants of their active involvement and enthusiasm during this session. Thank you, sir.
Thank you. Thank you so much for all.